Hello. So, since my last video, I've been mostly doing a lot of learning, um, learning some game engine stuff, more Apple. Oh, I got all out of focus. A lot more Apple Metal than OpenGL. So, I think this video I'm just gonna show that stuff. Why am I making two game engines at the same time? I don't know. I'm bored. I I get bored with stuff, so I switched around. So sue me. Um, but yeah, I've been working on the Apple engine for a little bit longer. I did show it in one of my videos. I think I did. I don't remember if I did. But I will show it in this video. It's similar to the OpenGL one, not as far along, because I haven't added lighting to the Apple one, and I've done some refactoring in the last few days. I will add lighting to it. I kind of want to just get it to the same point as the OpenGL one, and I'll probably just keep flipping back and forth between each engine. Besides that, I have a lot of workout footage that I hope I didn't accidentally delete. But if it's in there, if it's in my phone still, I will put that in there. Continuing with my workout program, I've stayed fairly consistent the last 2 weeks, so I'm happy about that. I'm actually going to tour a powerlifting gym, so if I can record anything from there, I will. But let's just take a look at the engine. It is called Baby. It's named after the rapper Sa Baby, who is my favorite rapper. All right, let's take a look at what we got here. So, this is using SwiftUI and Metal Kit. Metal is basically Apple's version of OpenGL or Vulkan. It's closer to Vulkan than OpenGL. It's more modern. What makes it modern? I don't really know. I'm not an expert on graphics APIs, but I have been told that it is modern. I have read things. So yeah, basically it just we just are rendering a big red cube, and we're able to walk around it like a first-person shooter. Cool. Very similar to what I had in OpenGL. So to do that, what I am doing is, well, first of all, we have a view that has a renderer, which is a class that I created. If you're making a metal game engine, you would probably also have a class called renderer. It renders. And because Metal Kit uses UI kit view, you can't just do a SwiftUI view, so you have to do this NS view or UI view representable. So I have extensions for that, and then I just have an if. statement to check if we're on iOS or Mac OS. On Mac OS, the views in UIKit are called NSView. In iOS, they're called UIView. So we have these extensions, and both extensions are just calling the setup view function. And setup view just creates an MTK view, which is a view included by MetalKit. I actually don't need this import game controller here. So I was handling input in this view before, but I refactored it. All you're doing here is you're creating a view. We're setting the device to a metal, or grabbing a GPU basically. So I'm gonna put this on do not disturb. Yeah, so we're grabbing a GPU. We're setting frames per second. We're saying to display it. We're going frame buffer only. We're setting that to false, which I forget what it does. But I want it to be false. What was that again? Oh dear God, no. True online allocates textures and only render target. Blah blah blah. Okay, I think it's just an optimization thing that I do not need. We set the size of the drawable of the view. We set the depth stencil pixel format. Basically, that is to check the depth stencil test to see what's in front of what. So, if you watch my video 2 videos ago, I believe I explained that in OpenGL. It's the same thing here. We're setting is pause to false. So if it's pause, it would only render 1 frame. This one, we're allowing it to render 60 frames per second if our rendering is fast enough. And then we just set a delegate on the view to my renderer. So let's take a look at the renderer. So renderer here just sets up a bunch of stuff. We have our device, we have a depth state, we have a pipeline state, which handles like if you have different shaders that you want to compile for each different for a different like render pass, you can have multiple pipelines. Right now I only have one pipeline. We have a command queue, which just handles creating a command buffer that allows us to send commands to the GPU. Yeah, and I have this last time, which just gets the current time. That is for setting the delta time. I have a flag that just says whether we want to render wireframes. So if I set this to true, it would do this. Wait. It's reloading. It didn't work. Okay. What the? It should render lines, but I don't know. Maybe I did something wrong. Let's see. Or I deleted that code. Huh? No. Oh, okay. I'm not rendering the model like that. Okay. I'm silly. Wait, I think I need to. Oh yeah, I need to set this up here. I think if I put it before I render the model, render the scene, it will. Okay, there we go. Okay. Yeah, so basically this just shows the vertices and the lines, the triangles, in case you have to debug something. So, but don't want that right now. So I'm gonna go ahead and set this back to false. And then we just have a game scene. I will go through that in a bit. I don't think I'm using this anymore since I what's it called? Refactored But basically that was allowing someone using the engine to pass in their own input code. But I'm not using that at the moment, I believe. So if I delete it, yeah, still succeeding. I just did a major refactor, so that's why I have all this junk here. But yeah, again, when we initialize the renderer, we are setting the metal or using metal to grab a GPU. If not, we're going to say unable to get GPU. We set the device. We grab a library which handles the actual shader functions. So we create the functions. One's called vertex shader, one's called fragment shader. They are here and here. So if I go back to renderer, we do the depth test here. We say if it's something less than or equal to, we will not show it. If it's behind something, don't show it. Probably could just do less here. So, and then we enable that. And then we create a depth stencil state. So we set the depth state there. We create our game scene while passing in the device. We describe our pipeline, and to do that, we just set the vertex function, the fragment function. We set the pixel format. So for this pipeline, we're just sending in colors in the format of blue, green, red, alpha. Each color is just an 8-bit unsigned number. And we set the depth attachment pixel format, which is something I'm not going to explain because it's confusing. Well, it's not that confusing. It's just something you got to know. If you want the depth test to work, you just set it as this. Okay. Pipeline state descriptor. We're setting, we have a static function that creates the vertex descriptor. So vertex descriptor is just a way to describe what is being sent to the vertex shader. So if I click that, we're just setting some attributes. So the first attribute is, what's it called? Float 3, which is the vertex position. Next one is normals, which is another float 3. And then we have texture coordinates, which is a float 2. We're all sending that over to the old vertex shader. And then we set the pipeline state here. And we make the command queue. Again, fatal error if it fails. We set it. And then we have these two functions that are required by metal, the MTK view. We just have this method that just resizes the window. So if this is called, we will resize our scene, passing the size. And then in draw, we're just creating a render pass descriptor. We're making a command buffer from the command queue. We're labeling them and then grabbing our render encoder from the command buffer, labeling that, setting the depth state and the pipeline state. Here is where if you have multiple render passes, you can create different pipeline states. Right now I only have one. We're creating the delta time, which we are passing to the scene to update. And then we are rendering the scene, and then we're ending the rendering. We're setting the drawable, and we're presenting it, and then we're committing to the command buffer. And that's all we really have to do to render that cube. If we go over to the game scene, this is where I hold my camera, my controls, and my models. The last delta is just the last location that the mouse was. I probably should call this last mouse delta, actually. Okay. Yeah, so in the init, we're just creating a cube and we're appending it to the models. On the update, we're just updating the camera update. All it does is resets the aspect ratio, so things are not distorted. In update, we're checking for which keys have been pressed. If it's WSAD, we pass a direction to the camera, and then we are processing the mouse movement only if it's moved more than this amount. So, because of floating points and stuff. Okay, so what else? Oh yeah, and then we're just rendering. So we're creating a transformation from the camera. We're setting all the stuff on the transformation from the camera. I probably could just make this a computed variable on the camera. You know what? I'm gonna do that right now. Because there's no reason to like be creating it there. So I'm just gonna say var transformation. Sure that still succeeds. Cool. Okay, then I can actually just replace this with transformation. Okay, so this has to be a var though because it's an in-out variable, so it can be changed by the vertex shader. But yeah, we're passing it to the GPU using this set vertex bytes. And then we're just rendering each model in the models. The model is just a protocol, and Cube implements that protocol. I'm planning on adding more models. We're gonna start with just like primitives. So right now I just have Cube, and then I'll add like, I don't know, triangles, plane, squares, not like airplanes, like a flat plane, like a flow. What else? Let's actually make sure this still works. Yep, cool, still works. And let's see. Camera is honestly, it's just like a bunch of math. It's pretty much the same camera from learnopengl.com, just translated to Swift. Yeah, and then I have a small math library where I just created some functions that do math for me. Yeah, anything else? Oh yeah, the shaders. So not a whole lot is happening in the shaders. TBH, we're just passing the transformation in and the vertex, and then we're have the out variable. We're just saying out.position equals the transformation, or the position times the three matrices on the transformation, and then we're returning it. Fragment, all it does is return a color. But as you can see, there's commented out code for lighting that I will implement soon. I have not implemented textures either, so I have to do that first. And then I will, after textures, I will add the lighting stuff. Probably just gonna do the same thing as the OpenGL one with the container, and then move towards like actual models a little bit later. Anything else? There's the beginning of lighting. I just have directional light and point lights. Like the other one. Let's see, anything else interesting in here? Not really. Oh yeah, controls. Yeah, controls are somewhat interesting. So we are importing Game Controller, which is an Apple library, and all we do is check the notification center for when the keyboard and mouse connect, and then we set a handler. So if a key is pressed, we insert a key code. If it is released, we remove it. And for the mouse movement, we just set the delta, which is how much the mouse has changed in position to it. And as you saw before in the game scene, we're saving what was the last mouse delta. So we use that to subtract to get the new mouse delta. Yeah, that's about it on this. So should I just name this video? I'm making a Apple Metal game engine for no real reason, because people really clicked that clicked that video a lot, more so than I thought. That was my most viewed video, so hopefully y'all keep clicking. But people are much less interested in metal, I'll be honest, than OpenGL, so I don't expect this video to do as well. But I enjoy Apple development. I'm an iOS developer, so I will be learning both. The good thing is that things very easily translate between different graphics APIs. Yeah, I feel like I'm making the center stage on my phone go nutty mode right now. I'm moving around too much. Okay. Anyway, my friend is on the way. We're about to go to the gym. Thank you for watching.